Today we'll discuss about 2D motion, right? I'll start with the basic concepts of 2D, then we'll go for problems and all. So two dimension, it can be like we need to have two dimensions, x, y, y, z, x, z, any combination of things. So let us take this as x axis, y axis. The best part here, both are generally independent, right? So x is separate, y is separate. You might give a condition where x should be equal to y or x is equal to y square. So based on that, the path of the body will change. If we say y is constant, suppose for a particle y is constant, so this is the motion of it. So straight line, right? X is constant is this. X is equal to y is this line. So we have different combinations, right? So equation of x and y. So in our syllabus, first 2D motion means projectile motion. So before that, we'll go with a body having constant velocity along x, constant velocity along y. Suppose if they say Vx is 2 meters per second or Vy is equal to 3 meters per second. They might ask you, what is the equation of the path, right? So xy coordinate system. So here Vx is 2, right? So what is the x value? X is equal to 2t. Velocity is constant, right? So x is equal to how much? 2t. Our velocity in y direction is 3, it is constant, so y is equal to 3. Is the easiest one, basic one. The particle's velocity in this direction is 2 meters per second. That means in second it will cover 2 meters. In this direction, 3 meters per second it will travel 3 meters. So here, how to get the equation, or they say equation of the trajectory. What is the equation of the path of the particle? Equation means the relation of x and y. Or if z is there, x, y, z relation. Or y, z is there, y and z relation. So like that. So here we have x and y. So they're asking the relation of x and y. So what is the variable here? T is the variable. So we have to eliminate t. Just you can divide, right? X by y is equal to 2 by 10. This is the equation of the trajectory. Or in terms of y means y is equal to 3 by 2x. Y goes this way, 3 by 2x. So 1.5x. So it is a straight line. This is the equation. Y is mx. If you remember, y is equal to mx is the equation of straight line passing through origin. So how do you know it is passing through origin? When x is equal to 0, y is equal to 0. X is 0, y is 0. If x is equal to 1, when x is equal to 1, y is equal to how much? X is equal to 1, so 1.5 into 1, y is equal to 1.5. So when x is equal to 1, y is 1.5. So this is the point. So this is a straight line. The particle is going along this line. And here you can say tan theta, if this is theta, tan theta is the slope, which is 1.5. This is the easiest one they might ask, right? Relation of x and y when particle is going with constant speed or velocity. So if they ask what is the velocity of the particle or speed, speed is equal to mod v bar. V bar if it is the vector, mod v bar is the speed which is equal to root of. I'm just pausing things. Yeah, now I'm muted all. So here it's root of 4 plus 9, root 13 meter per second is the velocity of the particle. If they ask you x coordinate of time t, substitute the t value. Substitute the t value here, you'll get the x coordinate. Similarly, substitute t, you'll get the y value. Right? Done with this basic one. Is it clear? Chat now you can say yes or no. Okay. So next one, projectile motion. Don't worry guys, I'm recording this class, I'll be posting it. So even if you miss it, it will be good. But better if you attend the class. For people who have missed it, I'll be posting it online. Let us see how it goes. So the projectile motion, the basic projectile motion, we have this x-axis. I will explain all the terminologies, things so that you won't be getting confused and all. So when you project a particle with velocity, it is called initial velocity. The angle with the horizontal, I'm telling you, angle with the horizontal is theta. If in question he says in the vertical it is theta, be awake, be conscious, learn, read the question properly, between the lines, through the line, everything clearly. So theta is with the horizontal. And normal projectile motion, we have only downward acceleration ay, which is equal to g. it is downward. So if they ask you upward is positive, downward is negative. So velocity components in the horizontal direction are u cos theta, resolution of vectors. So how to resolve a vector? If there is a vector A bar, there is a line like this. If it makes an angle theta with this, what is the component of A along this? A cos theta. Component of this normal to this line, normal to the line, this line, okay, which is A sin theta. It's very easy. Resolution is the easiest thing in physics. You can say A, there is a line about which you need the component, so A cos theta. About a line normal to this, A sin theta, right? So if instead of this, they ask you, there is a two straight lines like this and 90 degrees. So here there is a vector B. If this angle is theta, what is the component along this axis? So this will be B sin theta. This will be B cos theta. So you know along this is B cos theta, the other one is B sin theta. You just be very careful. What is theta? That's it. The only mistake what people doesn't get confused. So already normally they by heart like theta is with the horizontal, but in the question they'll give you the vertical. That's it. Don't guess. So it should be very clear with what particular axis is giving the angle theta. Right. So here, one second, let me check. Here this component will be u sin theta. Here horizontal acceleration is 0. There is no force. Normal, if wind and all are not there, horizontal acceleration is 0. The particle will go with constant horizontal velocity u cos theta. So at any instant, x component is u cos theta into t. X component is u cos theta into t. And y component, so this particle will go like this because of the acceleration g downwards. While hitting this, it will hit an angle theta. Y horizontal remains same. It will go with u sin theta. It will hit with u sin theta. So this component will be u cos theta. This component will be u sin theta. So the resultant still makes an angle theta with the horizontal. So here this angle is theta. If they ask you what is the change in momentum, the same question they might ask in projectile motion. Total change in momentum, delta p, change in momentum. Mu cos theta remains same. What is that change? Mu sin theta got changed. So it is minus 2mu sin theta. Final is minus mu sin theta. Initial is mu sin theta. So minus of minus. So minus 2mu sin theta. This is delta p, change in momentum. Right? Okay. So x is u cos theta into t. So how to get y? So you know basic equations of this kinematics. S is ut plus half at square. Y is equal to u sin theta t minus half g square. This is the x component, this is the y component. So what about the velocity? These are the components means position. So when the particle is here, this is the x component, this is the y component, this is the xy. So remember, as I said, if you need to find the equation of projectile, trajectory of the particle, what is the variable here? T is the variable. We have to find out the relation of y and x. So you have to eliminate t. From the first equation, t is equal to x by u cos theta. Substitute that here. Y is equal to u sin theta into x by u cos theta minus half g t square. T square is x square by u square cos square theta. So here u gets cancelled. We get x tan theta minus gx square by 2u square cos square theta. This is called equation of the projectile or trajectory of the projectile. Y is equal to x tan theta minus gx square by 2u square cos square theta. So any point on this projectile will satisfy this particular equation. Suppose there is a point maybe 4, 5 on this somewhere 4, 5 is there, or 3, 2 is there. Maybe this point is 3, 2. You substitute this point into the equation to satisfy this. So when you put x is equal to 3 here, put the theta value, put g value, then you get y as 2. That is the meaning of it. That is the equation of trajectory. So you should no need to understand. So once you understood, you have to by heart this. No need to derive this again. Only once you have to understand this. So here, what are the assumptions? The horizontal acceleration is 0. So velocity is constant. Only vertical direction velocities are changing. Rest all are remaining same. That's about the trajectory, right? Equation of the trajectory. We got it. So I'll just write the in short that equation y is equal to x tan theta minus how much is it? What was it? 1 second. Y is equal to tan theta minus
half gx square by tan
dx square by 2
theta.
square cos square theta. Good, nice. Again, I'm unmuting you all. Right. So here, this is the equation of the trajectory. Any point on the projectile should satisfy this, right? The next one, time of flight. Time of flight is time taken to reach from this point to this point. It is simple. If you throw a particle straight, it will go straight and come back, right? Even if you leave also, it will fall down. When you throw it, it goes up and comes down. If you remember, if you throw it with u, time taken to go up is u by g. While coming down, u by g. So total time of flight is 2u by g. So instead of u, we have u sine theta. So time of flight is 2u sine theta by g. 2u sine theta by g. The next one, range. The horizontal distance traveled is called range. How much far you can throw a particle is called range. So here r is equal to u square sine 2 theta by g. So how do we get the range here? When y value is 0, put y value is equal to 0. Then x value either 0 in the start or range at the end. So once you put y is 0, you get x has two roots. One is 0, one is r, which is u square sine theta by g. Then maximum height during the motion, the maximum height reached, x is equal to u square sine square theta by 2g. So u square sine square theta by 2g is the maximum height reached. So how we got this? S is again ut plus half at square. So or v square minus u square 2s at the maximum height vertical. So here if they ask you what is the velocity, only u cos theta will be there. Vertical velocity is 0. So in the y direction, v square, finally what is the vy? 0. Here uy, u sine theta. V square minus u square is 2as. Use that formula, you will get this h is u square sine square theta by 2g. So these are the formulas you have to remember. Why is one is this equation of the trajectory. So recap करो, notes में लिखो, बार-बार repeat करते रहो. You should be revising it whenever you get time. Unless until you remember that, you should be revising, recapping it. So these things, maybe to use sanitizers you remember. This sometimes you might forget or this or this. Chance of forgetting this is more. So try to revise it more time so that you can remember that. Right. So when is this range maximum? So if you try to shoot a gun, so when you shoot it like this, it will just hit it here. As you keep on increasing the theta, when you keep on shooting like this, here it will again fall down here. So people found out when theta is 45, the particle got maximum range with the given velocity. If you got a gun, for a given gun, depending on the functioning of the gun, the muzzle velocity is constant. So now the word muzzle velocity, what is meant by muzzle velocity? The maximum velocity with which the bullet can come out of the gun. So if you're running with the gun and then shooting, no, you'll have more velocity. If you're going back and shooting, you'll have less velocity. You're standing there and shooting, it'll have that maximum muzzle velocity, right? So for a given muzzle velocity, if theta is 45, we'll get the maximum range. Theta is 0 is 90, it will fall down only. It won't go anywhere, right? So next, they will ask you what is the another question. Suppose there is a gun, someone is shooting like this, so they are kind of going in a circle. How much area they can cover? So once you got the range, so range is the radius. Now they are shooting it every direction. So area is equal to pi capital R square. So these are kind of questions. Or they might say there's a water sprinkler through which water is coming at an angle theta. They'll give this is the velocity. Using that, you have to find out the area covered by a sprinkler. So they do this math, right? So you have to fit some fountains to a garden and all. I mean, these sprinklers. So you'll do, okay, this sprinkler will cover this much area. So, okay, these many sprinklers I want. That's how they plan and all. So that is the area. This is time of flight. Here, time of ascent, time of descent. Time taken to go up is time of ascent. Time taken to come down, time of descent. Total time of flight is 2u sin theta by g. This h is the maximum height during the projectile, which is u square sin square theta by 2g. Change in momentum, final minus initial. So what is the average force on the particle? So people might say average force, how to change delta P, then by total time. Change in momentum by time, do it. Change in momentum by time. So if you see, force is change in momentum by time taken. So 2mu sin theta by 2u sin theta by g. 2u sin theta gets cancelled. Mg, it is very easy. Particle is in air, no other force is acting on it. Mg is the only force which is acting on it, right? So what is the average force on the particle? Mg. From the start to end, the average force on the particle is mg. So these are the concepts you should know about the projectile motion. So if you cannot know the process or derive things and all, see that try to remember these things. Better if you understand the process so that things will be easy for you. But most of the questions will be easy. So if you remember things, it will be helpful. That's it. So let us see. So this is one 2D motion. Other one they will be asking you is relative motion. So in 2D we have relative motion. So one is rain umbrella questions, other one is a river crossing question. We'll do both. So river crossing question, if there is a river like this, if there is a person who had to like cross the river, if your velocity of river is VR, velocity of swimmer is Vs. So here this is A, the opposite point is B. You have to reach to the opposite. There are two things generally. One is reaching the opposite point, the other one, this is called shortest distance. The other one is reaching the other bank in shortest time. So if the velocity of swimmer is Vs or velocity of boat, either swimmer or boat. So if he swims this way, right? So if he's continuing swimming this way, river will take him to somewhere C. This will be the shortest time, right? So if he has to reach opposite point B, he has to swim at angle theta this way. Then some part of the component of the velocity is used to cancel the river velocity, right? The component Vs is this way, no? Vs cos theta. Vs cos theta will cancel Vr. Vs sin theta is used to cross the river. So first condition is Vs cos theta is equal to Vr to reach the point B. If this has to happen, velocity of swimmer should be greater than velocity of river. If he is slower than the river, he cannot reach the opposite point. So he'll be reaching somewhere else, because, right? He cannot cancel the river flow. So this is the first condition. If he can swim more than the speed of the river, then time taken is equal to distance by velocity. So this is the distance d by velocity. What is velocity? Vs sin theta. From this you will get cos theta. Cos theta is how much? Vr by Vs. So here d by Vs into sin theta is root of 1 minus cos square theta Vr square by Vs square. If you take common, d by root of Vs square minus Vr square. This is the time taken for the person to reach the opposite bank, that is the shortest distance. And the basic condition, again, people might miss here, is Vs greater than Vr. This is not happening. He cannot reach B straight away. He has to be going somewhere here and then he has to walk back. That is the only possible. To take auto, bus, whatever available there. But basic thing here it is Vs should be greater than Vr. That is first condition you have to check. This is time taken to travel shortest distance, right? That is just the opposite point. The next one is time taken to just cross the river in shortest time. So he will just use his total velocity to cross the river. He'll reach point C, right? In that case, the time taken is d by Vs. That's it. Time taken is d by Vs. In this time, what will happen? He will have a drift of Vc because water is not at rest. River will be pushing him, though he's like, okay, I just want to reach B, he'll be swimming this way, but river will take him to C, right? So the drift BC is called a drift. Drift BC is equal to VR into time taken. Time taken is d by Vs. This is quite easy to remember. If you can remember again, easy, or else you can solve also. And again, one more thing I just want to stress on this here, students. Paper is always balanced. It is us who are unbalanced, right? So it is the same paper for everyone in the country. The people who design the paper, God sends, they see, okay, this question takes this much time if it is done in this particular way. If you are choosing a lengthier way, they can't help you out. If there is 1 plus 2, you keep on counting 1 plus 2 like this, it will obviously take time, right? So you cannot say this is lengthy paper, that is difficult paper and all. It can be done in time if you learn the right process, right way to solve those questions. So please do understand, if you remember this, see now you are putting your hard work and remembering this. So you are using this hard work in your exam. If you are not doing this here or not remembering this, again you have to solve the whole thing in exam. That is where people lose time or they are using the resources in a wrong way. So please be careful. These are the basic things. If something else, new one is coming, yeah, you have to solve. Even I have to solve, everyone has to solve that question. So normal things, basic ones, repeated questions, please solve here now before going to exam. Write it somewhere, remember, try to repeatedly revising it so that it will be like, you can keep it in a right way. Clear? This is about river crossing, basic questions. So 2 questions, right? The next one is relative velocity. I hope you already remember we done relative velocity in 1D motion. So if you both of you are going in the same direction, relative velocity will be subtracted. If it is opposite, you feel like the other person is coming faster, relative velocity will be added. Again, this when both of you are on the ground. If one is on the ground, one is on the, you know, एक minute. For me, it is clear. Yeah. So here in relative motion, we have rain umbrella questions. So if there is a person, generally if it is a flat ground, it is easy. If a person is going this way, his velocity is some vx. So what do they say? Suppose I'll just take an example and tell you. When rain falls, it is not must, it always has to fall vertically. Why? If clouds are at rest, rain will fall vertically. But again, if wind is flowing, no, or blowing, so rain will go like this. So rain is actually trying to fall this way, wind is pushing it this way. Other one, clouds actually move, right? So when clouds move, the rain falling from this got some velocity, right? So rainwater, the drop water there in the cloud, it is like there, right? So when it is falling, even the raindrop got velocity when it is left from that, right? So here from the cloud has a velocity because of it or Vx. The raindrop has Vx. Or due to wind, this may be at rest or here also it has velocity extra due to wind. So what matters for us is not what is there up. What matters to us, what is the velocity when it is hitting us. That is what matters for us, right? So here, suppose when rain is hitting this guy, vertical velocity is Vy, horizontal velocity is Vx. Vertical velocity Vy, horizontal velocity Vx. So here, now if you see this question carefully, if this person stands like this, he will feel the rain resultant velocity is this way. Okay, let us bring this person here. So he will see rain is coming this way. So he has to hold his umbrella this way so that he will compensate it so that it won't hit him. Right. Now he has to see that if he has to find that rain is falling vertically to him, he has to run with velocity Vx. Now it is like ball is coming like this. He has to, the fielder is running and catching the ball, right? So he's only compensating or holding the vertical velocity. Same way here when he runs with Vx, the rain's Vx, his Vx got compensated. What he sees is only Vy. So in a question they say a person is running at 3 meters per second and finds that rain is falling vertically. So his velocity is how much? 3 meters per second. And he finds out rain is falling vertically. What is the meaning of it? The horizontal velocity of the rain is 3 meters per second. Then next point he might say, there may be different possibilities. So next one he might say, uh, he might come back, he might run in the opposite direction, he might run in the same direction with a higher speed, lower speed. Depending on that, the relative velocity will change. Suppose, let us assume, if he says in the question, if he now runs at 6 meters per second, so he's running faster, no? Initially when standing, it was this way, hitting this way. So he's running faster, so when it's 3, it is falling vertically. When it's rest, it is hitting from this way. When he's running at 3, it is falling vertically. So what will happen when he runs at 6? It will hit him like this, right? So it's running at 6. What is the relative velocity of it? 3 this way. So Vy will be this way. So it will be hitting this way. So here if it is theta, here also it will be theta. So he was initially holding the umbrella like this, so he has to hold the umbrella like this with the same angle. So I might ask you what is the angle at which he has to hold the umbrella so that the rain will be hitting him at particular angle theta or whatever. So again, it's about to be done. I'll stop this here. Again, I'll restart this session. Just a minute.